Okay, thanks for introducing. My name is Takuto Asakura. I was so blown away by the presentation from Barbara because I only lived for the years after the 20th slides of because I believe I born in 1995. But anyway, today I'm talking about the modern Japanese tech in 2026 this year. But it's the story about the chaotic situation in Japan related to the TeX system. So today I'm only want to talk about the rough, brief, and brief idea of the what TeX system in Japan are. So I'm not going too much into the technical details. But I want to first talk about the key differences between Japanese and English typesetting because I believe for most of you, Japanese typesetting is not familiar with. And for the second part, I would like to talk about the LuaTeX system used by Japanese people nowadays. And finally, I will talking about the recent trends and the problems in the Japanese tech community nowadays, what we are holding. So let's starting from the differences between the Japanese and English typesetting. So there are, roughly speaking, three big differences between those two typesetting. So the first large group are the difference of character set and space modeling, of course. And the second groups are the difference of the rules of line breakings. And the last one, which is obvious for Japanese people, but probably not obvious for English speakers, because if we call Japanese typesetting, it's for the most cases not ends up with only Japanese text, but it's kind of mixed script composition always, because most of the ideas, specifically in STEM documents, are imported by the foreign country. So we also include some numbers or English words, some other things from the foreign culture. So it's naturally become a mixed script composition, which makes also a situation a bit different compared to the English text. So talking about the first large group, which is the character set and space modeling divergence. So the characteristics of Japanese character are fixed widths, while the English texts are normally variable widths, like shown in this example. So for the English typesetting, you normally build the rhythm with the variable widths with glyphs like shown in the example, while Japanese letters are always square and fixed with positioning to the right next to the former character, which makes quite simple for the normal situation, as clearly can be seen. But some problem we don't have the interword spaces, so we just put the word together. So there is no obvious separation between words in Japanese. So the line breaking logic are quite different in Japanese typesetting. So for English documents, the candidate of line breaking are mainly at the position of word segmentation, or you can possibly line break in the hyphenation position. While for the Japanese texts, we can break virtually everywhere. So you can put line break everywhere you want for the normal situation. But there are some exceptions. So instead of having the simple rule for the normal placing the characters, we have a relatively complex rule for line breaking prohibitions. So there are mainly two types of them. The first types are the no intervals, the first categories of the prohibition is no break before, and the second type are no break after. So for instance, for some symbols like period and comma and punctuations and other closing brackets cannot come to the beginning of the line. I think it's also applied to English, but those are the first half of the categories. And there's also other groups that are forbidden to put at the end of the line, which is the opening brackets or long dash and so on, cannot come to the end of the line. So in Japanese typesetting, you can put almost everywhere for the line breaking, but there are some exceptions. And like I'm going to talk later, this kind of mechanism implemented directly in the Japanese specific version of TeX engines. Yeah, and I think that's, yeah. And the last big group of the difference between Japanese and English typesetting is the common situation of mixed script composition, which is, like I said, most of the Japanese documentation, specifically the STEM documents, which typically LaTeX applied, scientific documents, which also includes the Latin letters inside the documents. So it is a quite common situation that the several scripts share a single line. And for those situations, there are another special rule in Japanese typesetting. So we have to put some special automatic insertion of appropriate spacing between at the border of the script switch. Like if you start English Latin letter inside the Japanese letter, you have to put small spacing before you start English, and of course after ending the English words. So these also have to be addressed by the TeX mechanism. And yeah, of course, if we mixed the Japanese type letter and English chunks inside a single line, then we also have to combine the different line breaking logic at the time. So if the English terms appears at the end of the line, then the English line breaking system would be applied, while the Japanese letter comes at the end of the line, then Japanese line breaking should be applied. So it's a bit a complicated situation. And yeah, we also have we also need some adjustment of baseline and glyph size harmonization. So those kind of things should be treated if you want to properly typeset Japanese documents. And there are also some other unique features for Japanese typesetting, which is maybe some of you knows that we Japanese and some Chinese, and I'm not sure about Korean, but we have the vertical writing. So we start from the top to the bottom, from the right to left, kind of progressing. And in recent years, at least for the STEM documents, we use horizontal text rather than vertical writing, even in Japanese text, but vertical writing are still used in newspaper or literature or some specific fields. And we also have some very specific layouts traditional layouts in Japanese. For instance, we have Ruby, which is an annotation glosses to show the pronunciation of the letters. And we also have some special type of notes. So we put 2 lines in the single line instead of a footnote or the side note, and in some cases. And we also have a special type of emphasis mechanism. And also we have some quite weird situation that we have a sudden horizontal material inside the vertical text, which is obviously a complex situation that you can easily imagine. But these are relatively minor and less important issue for, at least for scientific writing, but still, if we want to have the complete Japanese typesetting, then we have to address this kind of material as well. So those are basically the reason why we had to implement our own special Japanese TeX engine quite a while ago at some point. So let's proceed to the technical side of this kind of Japanese typesetting, which are the TeX and LaTeX system for Japanese typesetting, which are used recently. So currently, we have 2 practical approaches for producing Japanese LaTeX documents. The first, and I'm afraid it's still dominant workflow in Japan, which is quite ancient technology, but they are the pTeX variants plus DVI PDMFX workflow. It's even older than PDF TeX because it's produced DVI instead of PDF. So it's an original Japanese specific extension maintained since 1990s. And its unique, its characteristics are the support for Japanese font metrics, which I will briefly explain later, and native line breaking precipitation, like I showed, and vertical typesetting and other minor features, which would better to have for Japanese typesetting. And more, the second approach is a modern one, which is LuaTeX-based things. We have a special huge macro package called LuaTeX-ja or LuaTeX-ja, which is basically TeX and Lua codes so that to realize the proper Japanese typesetting on top of the LuaTeX engine. Obviously, this is a more modernized and ideal way of doing things these days because LuaTeX is intended to be international and standard engines these days. But we also still have some problem with the speed because this LuaTeX-ja implementation is heavily relying on Lua implementation. So if you compile hundreds pages of the huge documents, then the time difference of compile can be substantial. So that's partially the reason why people are still using pTeX on 2026. So talking about a bit detail of the pTeX, like I said, the most important feature of pTeX is support of Japanese font metrics, which is a per character class setting for with side bearing kernings and also auto insertion of the glue between the script switching. And also the primitive implementation of line breaking, a special line breaking rule in Japanese typesetting. And also it also supports the vertical writing as well. And they have the special command to switch the horizontal and vertical typesetting. And basically, the LuaTeX-ja is a kind of re-implementation of this feature. So it had intended to make a kind of similar interface to pTeX, but because of the technical because of the technical reasons, some interfaces are different, but basically those implementation are realized via the flexible Lua callback thanks to LuaTeX. So pTeX is basically the legacy. So it's the basic idea of pTeX is just an 8-bit old-fashioned engine, but which is extended in terms of Japanese encoding, which is called this encoding. And this encoding is even old encoding, which are rarely used nowadays in Japan. So we already transferred to Unicode, of course. So we also have another type of pTeX, which is fully supporting Unicodes. So we have these two types of different implementation. But to be precise, on after the TeX 2024 onward, the binary is unified, but they have different modes so that to be compatible with the old pTeX specification. And what's the problem of the pTeX? Well, what's the legacy points of the pTeX? Basically, there are two important points. The first points are the encoding issue. We have the two different encoding we have to keep in mind if we work with pTeX. The first things are input encoding, which is, of course, the input encoding. So if you write a file in a certain encoding, then the input encoding for the pTeX should be specified or automatically judged by for the that specific file. But for the pTeX, they have the internal encoding can be differ from the input encoding. So for pTeX, they can accept Unicode as an input encoding, but they first convert it to the old-fashioned this encoding and then process and then produce the final PDF. So you can input the Unicode, but if you convert to the internal encoding, then you will lose some sort of information. So for pTeX, even if you input with Unicode, the full function of Unicode cannot be used. This issue are overcome by upTeX, but yeah, this can be sometimes confusion for some users of pTeX. And another burden is KCAT code, which stands for kanji cat code. This is a Japanese specific category code, as you can easily infer. So these KCAT code are applied for every multi-byte Japanese character, and the semantics are shown in this short list. And these KCAT code are used both for less-scale scanning, so whether, for instance, for judging control sequence separation, and also for line breaking and prohibition class lookup, so which can be also sometimes confusing because it's have the double meaning. And even worse, the specification are noticeably different between pTeX and upTeX. I'm not going too much detail in this talk, but you can refer to special documents, which is named Guide to pTeX Developers Unfamiliar with Japanese documents. So this document can be somehow helpful for people like in developer of LaTeX team. So those are the situation in pTeX. For the last part, I'm going to talk about the recent trends and the problem in the Japanese tech community. So these are, sorry, it's very biased history of LaTeX 3. But anyway, the LaTeX will kind of have experienced the code era of almost 20 years, which I call peaceful 20 years for Japanese developers. Yeah, almost.
So what do you conclude from that?
So yeah, from when I was born and until I was 20 years, it was a peaceful years. But now these 10 years, after the reactivation of LaTeX development, I understand it's an important thing and necessary thing for the internal community, international community of tech, but it is a bit complicated situation in Japan. So I'm talking about that point. So it's basically the pTeX and pLaTeX kind of things are a huge mountain of technical debt. So it's basically just a giant patchwork. So if some small change made to the original engine or the LaTeX kernel, which triggers a new cascade of local fixes for pTeX and pLaTeX kernels. And also nowadays, because of the tagging project and the full revision of the pLaTeX kernel implementation, they made quite a lot of changes, including the migration of font selecting systems or introducing a new hook system. So we have to catch up these kind of updates for the patching. But the real problem is that the Japanese community for the tech-related project developer are really severely limited manpower. We have only 1 or 2 maintainers for each project. We have probably 2 maintainers for pTeX engine and 2 maintainers for upTeX and 2 for pLaTeX kernel. And sometimes people are doing several just by one people. So it's really hard to follow all the lot of changes made. And so these are kind of very ad hoc first aid kind of fixing problems. So the root cause is basically the pTeX incompatible specification. Specifically, it's the token model. So like I said, pTeX and also the upTeX is just an 8-bit engine if Western developers look at. So besides of the multi-byte letters, the Western character ranging in 0 to 25 to 155 range, it's just 8-bit tech. And like I said, Japanese token have the specific KCAT code, but they don't have the cat code, normal cat code, which is also quite different from the world of 8-bit engine, which probably be a very confusing situation for the normal Western tech engine developers. And so for the practical breakage, if my understanding is correct, some of the export3 string related modules like L3 regex and L3 string convert module almost not working for pTeX as intended. And also sometimes they tokenize from the first place. That makes the 8-bit characters and Japanese token yields illegal token list, which is already the engine level problem, which cannot be fixed on the layer of LuaTeX. So what or probably the pTeX developers consensus is that it's impossible to fix all the problems within the paradigm of pTeX, but we need a radical fix of rewriting both the specification and the core implementation of the engine from the first place. Then we are not sure whether we should maintain pTeX from the first place in this case, because if we try to change the specification radically. And even worse, it is not just an engine or kernel level issue. This kind of giant patch technical depth problem also lasting to the generic Japanese documents classes and also other Japanese specific LaTeX packages. Some are already not maintained or maintained by the very few common, same single person like Yamashita-san, for instance. So we have the patch correction, the correction of the patching package for Japanese TeX, like for instance, PX array for patching a PL array for patching the array package for Japanese TeX and so on. So we have kind of substantial length of list of those kind of patching LaTeX packages, and maybe they are fine because it's maintained by the well-trained Japanese TeX developers. But the more problem is the journal or the society templates, which are basically developed and maintained by the amateur or the just normal user, I mean, in the publisher or some researchers. So I'm not sure if they could follow these radical changes that happens these days. So these kind of long tail legacies make a clean break from pTeX extremely hard or merely impossible. So yeah, that's the situation. But even so, we are trying to overcome this kind of situation by keeping our communication channels to connecting tight among the Japanese developer. So and those channels are mostly text-based, which are not so different from the international tech community. So we have the Slack channel and GitHub issues to discuss about the daily issues. And we also have the annual meetings in Japan, which have, I don't know, about half number of audience compared to TUG. And also there are npTeX concept, which is, I don't know, nipponTeX or new pTeX, which is discussed for, I don't know, already 5 or 6 years with almost no progress. That's trying to make a new engine which is compatible to pTeX but GTeX based, so that to make it legacy free. But the discussion very slow, proceed only slowly. And like you may know, on November 2024, LaTeX team announced that the end of full support to GTeX. So we are not sure if we move to GTeX can be a legacy free from the first place. So maybe transiting to the LuaTeX can be the only solution, but we still don't know. And where I fit in is just my personal note. I'm not an engine hacker, unfortunately, but I'm focusing on the documentation and tooling, like I introduced in the first. So I'm working on tech doc development and also try to engage with the global tech community, like presenting this kind of situation to the international audience. And yeah, I also translate the LuaTeX content to the Japanese, so I try to keep the connection between the international community and Japanese community. And yeah, this talk is exactly what I intended to bridge the gap information gap between the global tech community and Japanese tech community. So this is my standing point. So as the summary, Japanese and Western typesetting substantially different. And there are two practical Japanese workflows nowadays. And one is pTeX related things, which is a very ancient workflow. And because of that, it's a bit difficult situation nowadays, but we are trying to overcome with this by the collaboration among the Japanese community. And we probably need fresh contributors, otherwise it's really hard to overcome the situation with the, only with our manpower, which we currently have. Yeah, that's all from me today. Thank you.
Thank you, Takuto. Are there any questions for Takuto?
Hi. You mentioned that you have a lot of patches for different packages in order to make them compatible with pTeX.
Yeah.
How is that in LuaTeX-ja? You know what I'm doing. LuaTeX package. Does it also need a lot of patching, or is that more compatible?
Basically, yeah, LuaTeX also needs some patchwork. Maybe less than pTeX, but still we need LuaTeX, the patching for LuaTeX. And basically, the LuaTeX-ja is a huge macro package, and it also covers those kind of patching as the macro package layer. So not the third party have to work on, but the LuaTeX-ja community are working on. So they have a powerful main source, relatively powerful main sources.
Maybe if the questioner could announce their name, because we're not in the film.
Yeah, okay. My name is Didier Verna. I have a question regarding the Japanese-specific cat codes that you showed.
Okay.
You showed one cat code for kanji and one cat code for kana. My question is, wouldn't have it been more advantageous to have two cat codes for kana, one for hiragana and one for katakana?
Sorry?
Yeah, here.
Could you please?
Yeah, okay. The question is, why is there only one cat code for kana instead of, for instance, one for hiragana and one for katakana?
That is because for lexical scanning and line breaking prohibition, class lookup, there is no difference between hiragana and katakana. We can treat it in the unified form.
Okay, so there's no reason to distinguish them.
Yeah.
Thank you.
Hello, Matthew Scala here. I am aware of a piece of software called Satisfy, which seems to be, I don't know a whole lot about it, but it is something like a Japanese-specific engine that is not really tech. Is there any possibility of cross-pollination or similar interchange between that and the tech world?
Okay, yes, Satisfied, developed by a friend of mine, and he is also from the community of Japanese tech community. And I believe it is not Japanese specific, even if it looks like, but it's intended to be international. And it is completely different implementation, and it's incompatible with TeX in any aspect. So it's fully typed. It looks like a very function programming language. So it's, yeah, it should provide more meaningful error message for most of the situations. So it's the good point of the engine. But the downside is it is completely incompatible with TeX. So you cannot use the existing packages, documents, and any resources you already have. Am I answering your question?
Further questions?
I'm Carl Berry. So thank you, Takuto, for the great talk. And I wondered if you could tell us a little bit about how prevalent the use of TeX is, or LuaTeX, in Japan. Do most journals, most scientific journals use it, or not so much?
LuaTeX?
LuaTeX, just in general.
LuaTeX.
No, just LaTeX.
LaTeX, okay. Well, it's quite a lot. I think for the scientific, well, especially those involved with mathematics and equation, then it's almost 80, 90, 100% coverage.
Yeah, so that's similar to the situation here. So it's interesting that the same case of a few developers are being relied on by a lot of journals.
Yeah,
because it's exactly the same outside Japan, though, you know, that last few overlapping developers slide.
Yeah, well, I think so. But maybe double in the Japanese, but.
Boris, are there any online? No?
Yeah, I'm Marcel Krüger. I have one more question about LuaTeX-ja, and especially you mentioned that it's much slower, and that is a reason why it's not used much. Or
well, in my opinion.
Do you know if that's really if that's the only issue, or at least the main issue, or is there also on a future level something missing in LuaTeX-ja which makes people prefer pTeX?
Well, I think it's the same issue that Carl mentioned. So we have only very limited resource for journal and other long tail packages, and they are only compatible with pTeX. And I'm not sure they would know how to migrate to the LuaTeX. So they are lazy. So unless they are really becoming a problem that cannot be used, otherwise they are not going to fully step to the LuaTeX. So that can be the real issue of not realizing this migration. Thank you.
Last question.
Yeah, hi. My name is Frank Mittelbach.
I know.
I know you know. One question that I would have is, you said the nice years were ending in when we started to open the development again, basically. One of the reasons why we are doing a lot of these developments are in general to get some of the legacy debt solved, which of course cause more legacy problems initially. But the other one is, of course, our quest for getting accessibility into the engine. Now, my question to you would be, how much is accessible output from in documents an issue or how important is that in your world?
Pardon?
In Japan, how much drive is there to get to accessible documents? Because I mean,
By whom? By whom? By the LaTeX users or the
in the country. I mean, in Europe and in the US, we have legal requirements by now, so there's quite a push. Beside the thing being important in itself, there's suddenly some pressure. The question is how much pressure or how much interest is there to achieve accessibility? Because one of the reasons why you have the problems that we are making for you is because we are working on this. And if I may say one last thing, we are also only 4 developers. 5.
Okay.
Okay, so
the situation is only double severe. I know. Well, answer to your first point. This is my personal opinion. I don't know the statistics or we don't have consensus, but my personal point of view, it's a little bit shame that Japanese people are almost not concerned anything about the accessibility developers for the PDF documents. So the governments, as far as I know, are not care about the accessibility at the moment. And for the general public, it's even worse. So, and looking at the tech community, I would define myself, I am the only person who are interested in the tagging and accessible kind of, well, not really only, but just 1 or 2 people, including me, interested in. And then most of the tech LaTeX developers are kind of not really interested in the tagging or accessible kind of things. And this is because of the social attention and the values that are still not caring about the accessibility, because we are way behind, in my point of view, unfortunately. So that also makes this gap larger, because they have not really passionate to catch up with the accessible kind of things, which I want to somehow educate people, if I'm answering to you.
Thank you, Takuto. We'll have a short break, and we will be back at 11.
wow, it's like all of a sudden